Beneath the Philippine archipelago lies one of the most dangerous geological features on Earth, the Philippine Sea Plate. This colossal plate sits at the intersection of four major tectonic plates, creating ocean trenches so deep they make the Grand Canyon look like a scratch. The deepest point, the Philippine Trench, plunges an incomprehensible 34,580 feet below sea level. That is deeper than Mount Everest is tall. But the depth isn't what makes this area deadly. It's what is happening down there in the crushing darkness, where one massive section of the Earth's crust is grinding beneath another at a ruthless rate of 4 inches per year. This is a subduction zone, the engine of the most powerful earthquakes known to science, and alarmingly, it hasn't had a catastrophic rupture in over 400 years. This is not just a geological curiosity. This is a coiled spring, and its eventual release should concern everyone living around the Pacific Ocean. If you are fascinated by the hidden power of our planet and the geological forces that define life and death, you are in the right place. If you believe understanding Earth's most dangerous secrets is vital knowledge, make sure you hit that subscribe button right now. Let's explore the titanic collision that defines this zone. The Philippine Sea Plate is roughly the size of India, trapped in the Western Pacific. It is bordered by the Eurasian Plate, the Pacific Plate, the Caroline Plate, and several smaller plates. Where these plates meet, conflict is inevitable. The Philippine Sea Plate is being relentlessly forced under the Eurasian Plate along the Philippine Trench and the Manila Trench. This creates massive fault lines capable of generating megathrust earthquakes, which can reach magnitudes of or higher. Here is how these megaquakes work. As one plate slides beneath another, they don't move smoothly. They lock together due to friction, and pressure builds. Years pass, decades pass, sometimes centuries. The stress accumulates like a spring being compressed tighter and tighter. Then suddenly, the plates slip, releasing all that stored energy in catastrophic seconds. We have seen the horrific power of these events before. The 2011 Tohoku earthquake in Japan and the 2004 Indian Ocean earthquake were both triggered by subduction zones like this one, killing hundreds of thousands of people and shifting the Earth's very axis. The Philippine Trench system is capable of the same thing. The geological record confirms this threat is real. In 1918, a magnitude 8.3 earthquake struck the Mororo Gulf. The earthquake was devastating, but the tsunami that followed, with waves up to 30 feet high, killed over 4,000 people. That was a century ago. Since then, the fault has been too quiet. Geologists operate under the seismic gap theory. When a fault hasn't ruptured in a long time, the danger hasn't passed. It means pressure is building. The longer the gap since the last megathrust earthquake, the more energy has accumulated, and the more devastating the eventual release will be. The Philippine Trench has not had a megathrust earthquake in over 400 years. Geological surveys and GPS measurements reveal the plates are completely locked together, not sliding smoothly. The spring is compressed. It will eventually release. The geological structure here also explains the country's secondary disaster threat: volcanoes. As the Philippine Sea Plate subducts and descends into the mantle, water trapped in the rock boils off. This lowers the melting point of the surrounding mantle, creating magma, which rises to form volcanoes. This is why the Philippines has so many active volcanoes like Mount Pinatubo, Mayon, and Taal. They are all products of this ongoing subduction process. This creates a cascading risk. A major earthquake can easily trigger volcanic eruptions. The consequences of a megathrust rupture along this plate today would be severe. The Philippines' population of over 110 million, many living in coastal areas, sits directly in the path of any resulting tsunami. Manila, the capital, is built on soft, reclaimed land near the Manila Trench, meaning a quake could trigger widespread liquefaction, where solid ground turns to liquid. Furthermore, a large enough tsunami could cross the Pacific, affecting coastlines thousands of miles away in Japan, Taiwan, California, and Chile. Even in the trenches, we see a microcosm of human impact. Explorer Victor Vescovo, who descended to the bottom of the Emden Deep, a part of the Philippine Trench, found plastic waste. We have managed to pollute even this most remote, extreme environment. Yet life endures down there, with creatures evolved to withstand pressure that would instantly crush a human body. Human civilizations are not so adapted. While building codes are improving and early warning systems are being installed, preparation is expensive and often politically difficult. Geology, however, doesn't care about political cycles. The plates keep moving, and the pressure keeps building. The question isn't if the Philippine Trench will rupture, it's when. The deep trenches of the Philippine Sea aren't just geographic features. They are active, dangerous, and capable of reshaping the Pacific region in hours. The Earth is preparing. The only question is whether we will be ready when the next slip occurs and the power of the Philippine Sea Plate is finally unleashed. If you believe understanding this powerful geological threat is vital, hit that like button to spread the awareness. And to stay informed on the secrets that lurk beneath our feet, subscribe to BayanTube right now. We'll see you in the next deep dive.